You're a developer. You're getting ready to build your new project. What do you do first? Well, most of us would say that we just start writing code. And maybe, if there is time, eventually we might write some tests. But what if I told you that changing the order in which you code can change everything for your project? This is TDD, or test-driven development, a test automation technique that allows you to not only write better code, but also design it in a way that is more modular, testable, and overall more maintainable. Welcome back to the Semaphore channel. I'm Fernando, and in this video, we're diving deep into TDD. Essentially, we're going to be answering what it is, how it works, and why you should adopt it in your next project. So let's go. In test-driven development, we flip the usual script that we follow when we develop a new piece of software. We use test automation to run tests the moment something changes in your code. But instead of writing the code first and the test later, we make the switch, and now we write the test first and the code later. The core idea behind TDD is that you can't solve a problem until you properly understand it. So essentially, we start by writing the solution to our problem, the expected output, and then we work our way backwards until we find the code that produces that output. This brings us to the TDD mantra, Red-Green-Refactor. In the red phase, you write a failing test because you write a test expecting for code to work, but the code doesn't really exist yet. In the green phase, you write just enough code to make that failing test pass. And in the refactor phase, you clean it up and make it more maintainable. And behind the scenes, throughout the entire process, there is a test automation process that is running and rerunning our tests every time we make a significant change. As the diagram suggests, this is an iterative process. We'll write a small test that fails, then we'll write code to pass that one, and then we move into a refactoring process where we just make that code better and go back to writing another test that requires us to write a little bit more code, and then that requires us to refactor a little bit more and continue until we have the final solution. Kent Beck is credited for the invention of TDD. He said that the idea came to him while reading an ancient book on programming. And you can tell it was an ancient book because it said to manually type the expected output in a tape and then write the matching code that would produce that output. Apparently, this was a common practice back in the day when programmers would write code in tape. I mean, other programmers, not me though. I'm not that old, right? Regardless of when it was invented or who invented it, the biggest misconception about TDD is that it's about writing tests. And that could be farther from the truth, actually. Yes, you're writing tests while you're doing TDD, but that's not the point of it. The point of it is a mindset shift that happens when you stop thinking about writing code first and trying to solve a problem you don't understand and thinking about the actual solution, the expected output that you want to get out of that code, and then going back and through that iterative process, slowly improving on each iteration, you create a better piece of software. You create a more maintainable, a testable, a better designed piece of software. If you think about it, TDD is a way to clarify the problem before you even start working on it. Essentially, you understand it and then you move into the actual coding part. The tests are just the blueprints that you need to write the code. Now let's go into an example now and let me show you how you would go about using TDD in your day-to-day with your code. So let's imagine we're trying to design a checkout system. And since we're using TDD, let's write the test for it. So the first thing I want to test is the cash register class, which I haven't really created yet. So the first thing I want to test is I want to instantiate it, then add an apple, which would be an item, into a register, and then get the cost for it and make sure that it is the same as the expected cost that I have set up, which is 50. Now, if we run the test, we'll clearly get an error because the class hasn't really been defined yet. So there's nothing to work here. This test doesn't really work. So let's do that. Let's define the cash register class. This class right now is going to be very simple, which is the add method, which is not doing anything, and the get amount, which is returning 50. We're hard coding the price, and we're not doing much right now. Obviously, this class gets the test to pass. We're on the green now, but this is not really going to be useful. So we need to go into the refactor phase. Now, again, in our class, we're going to add a couple maps, the inventory and the prices, so that we use them as internal databases. Then we make sure to add the apple into our system, into our database, and we set the price to 50. We hard coded here, but at least it'll get the job done. Then we update the add method so that we're actually doing something. We're adding into the inventory the item that we just decided to add, the apples. And then we modify the get amount method, which instead of returning now a hard-coded 50, we do the process of looking the item up in the inventory and then calculating the final cost based on that. In this improved version of the class, now we have a more refined code, we have a better logic, and now we're ready to go back into a test and make new ones or improve on the ones that we have. So let's go back there and change the one that we have. Now going back to our test, we'll write again here, but we'll add a little modification. Instead of just adding the apple, we'll add another item. So the expected code is going to be higher. We're going to be adding pears here, and the pears is going to be $20 the pack. So our expectation here is that at the end, we'll get the right amount returned by the get amount code. Now, clearly, there is a problem here because we know that apples are part of the database, but pears are not. So here we have to face another problem that we haven't really thought about it before. What happens when we add an item that's not in our prices database? There should be code for it, but first we need to understand what's our expectation. What do we want it to happen when we add something wrong, essentially, when we add an invalid item into our checkout register class. And that's what we're going to be looking at in the next test. Now we want to add another test. We don't want to add the extra checks into the existing test because that will make this test in particular more complex. Our expectation of this test is that it will charge the correct amount. That's fine. So let's go into creating a brand new test inside our testing class here that will only take care of checking what happens if we add a new item that is not part of our pricing lists. So let's just make sure that when we add an item, we throw an exception. In this case, we want to throw an illegal argument exception when we add something that we don't know what it is. Now, we have our new test and the test is going to fail, obviously. So let's go into the coding to make it green. All right, so for us to make this green, we have to do two things. First, we'll just add the pairs to our pricing database so that the previous test also succeeds. Because remember, we had added the pairs to that one, but they were not part of our pricing database. So that test was also failing. Now, going back into the add method, which is key here, we'll have to check first if the item that we want to add is part of our inventory, is part of our pricing database. So that's what we do here. We check in our pricing database if the item is contained in it. If it's not, then we throw an illegal exception. Otherwise, we just move forward with the rest of the logic that we had already put in place. And that will make both of our tests green. So we're good to go. By now, the process should be clear. We have still a lot more work to do on this class. Clearly, there are still problems with it. You have hard-coded prices. You don't really have the ability to add multiple items at the same time. All these requirements can be solved simply if you put them into individual tests and then, again, go through the process, go backwards to writing the code that makes the test pass, refactor, and so on. Remember to add small improvements of code on each cycle. Don't go all in. Instead, just iterate in small steps until you find the right solution. If you think about it, TDD, especially for teams that are either new to software development in general or the teams that have been working on a completely different way, on a traditional way, if you will, implementing TDD will require a significant effort at first. So what kind of return of investment, if you will, would we get from this effort? So the first thing is we get better design and more modular code. Think about it. Writing the test first forces us to think of our code from an external point of view. Essentially, how is our code being used by others? That leads to more modular code, better APIs for our code, and even more testable code, because we are writing code that is compatible with an external user from the get-go. Another benefit that we get is test coverage. It's a very trivial one if you think about it, but it's a major one if you think of the long run and the long lifespan of a project. because that test coverage, as long as it keeps up as your code keeps growing, then it means you have sort of a safety net when you make changes, and when you refactor a piece of code or add a new feature, essentially change a single line of code, you know that that safety net is going to let you know if you made a mistake that causes something else that you were not even thinking about to fail, then the test automation will help you there. And finally, while it's not a technical benefit, that dopamine feeling that we get when all the tests pass and we get that green 0 errors message in our console, I think that it's really hard to deny that it's also a great feeling and a great benefit that we get out of the TDD experience. Clearly, in TDD, it's not all sunshine and rainbows. There are problems. There are pitfalls to watch out when especially when you're a team that is new to TDD. Sometimes we go the wrong way. For example, not using automation. While you can say, fine, I'll just manually run all the tests before I push code to production, the reality is that that will not happen every single time. It's not going to happen. We can't rely on us to run the test and make sure that we properly checked everything before we push our code, because there are bad days, there are days that we're in a hurry, that a hot fix needs to go into production, and we just decide to suddenly skip one test and say, you know what, I'm sure it's fine. We've seen problems recently on major systems that have affected millions of systems because the testing process wasn't respected. So let's make sure that you set up automation so that you have 100% reliability when you push something. Every single time you do it, through your CI/CD pipeline or through a pre-commit hook on Git, you can definitely set many automations to make sure that you are not responsible for running those tests, but rather an automated process. This will ensure that whenever code reaches production, at least it went through the mandatory set of tests. Another mistake is tight coupling, essentially coupling the logic of your test to the actual implementation of your code. Remember, the way we are thinking about TDD is you set an expectation. You think about the behavior of your system that you're testing and then write a test for it, eventually using that test as a blueprint to go back and write the code. Now, if you think about it that way, the actual implementation is decoupled from the test. The implementation has an implicit behavior, but that is what you're testing in your test. Whether you use an if or a while or a for loop, it doesn't really matter. Make sure to write the tests thinking about the output and the expected behavior, which is also known as BDD or behavior-driven development. And don't really force your tests to go inspect the actual element that you're testing and see internally what is happening. You can definitely do that in some other instances, but in particular, if we're looking into TDD, this is not what you have to think about. You have to design your classes, your modules, everything in a way that their behavior is what is visible, and that is what can be tested on your unit tests. Another common mistake is over-engineering your tests. And I kind of hinted at it when we were looking at the previous section in the coding example. When you have multiple things or multiple behaviors or multiple expected outputs that you want to check out of your module, your class, just split them up into different unit tests. That way, each individual test will fail or signal success on a single element, on a single feature, or a single expected behavior. If you add up multiple checks, if you add up a complex logic inside your unit test, then when something goes wrong, you can't really tell which part of it failed. Was it that you passed more elements? Was it that you were adding an element that was unknown in your database? Or was it something completely different? So make sure that your tests are simple, that they test a single aspect of your behavior, and then add multiple ones to ensure that you cover everything. And finally, neglecting the refactor phase. Remember, the mantra of TDD is red-green-refactor, not just red-green. You can't just keep going red-green, and then hoping that at the end, with enough tests, you'll have a complex enough piece of software that will solve the problem that you were trying to solve. Mind you, maybe you will, but the point here is that through the refactor phase, you get there faster. You make sure that the overall system, the overall code that you're writing makes sense together. It's not just a set of individual methods to make some tests green, but rather that they work in unison, that they work holistically. So don't skip the refactor phase. It's crucial to make sure that the quality of the output is also quite high. Now, in line with the problems that TDD has, there are also a lot of developers out there that are strongly against TDD, and they might have very valid reasons. After all, TDD is not a silver bullet that solves all problems. You have to make sure that the methodology associated with TDD makes sense for your project, your team, and your overall context. However, some of their counter arguments against TDD are just based on misunderstandings of the methodology. So let's go over some of them to understand if they make sense or not. The first one is that TDD is time consuming. The fact that you're writing tests first and then just writing the code is actually counterintuitive, because you spend more time writing code, you spend a lot more time developing through this Red-Green-Refactor phase, and in the end the project takes longer to finish. And that's not true. In fact, TDD has been proven to improve overall development time in long-time projects. And this is because once you get past the initial hurdle of making that switch in your mindset, making sure that the entire team understands how to work in this new workflow, then you get better code, you get more maintainable code, you get more stable code. So in the long run, when you have to make refactors, when you have to add new features, when you have to extend the code that you have the tools and the stability to make those changes and go faster. So while in the short term, it might look like you're wasting or investing, if you will, more time into your project that you normally would, and you're advancing at a slower pace, the long run, and which is something you should also think about, in the long run, you'll be able to move faster because you have that base stability that otherwise you wouldn't get. Another one is that TDD is just unit testing. And again, that couldn't be farther from the truth. We kind of covered that already. TDD is not specifically tests, but rather a way to think about the problem and the expected solution before you actually write your first line of code, which is a very good practice. That way you know where to go with your code. And not only that, but through the test, you get that blueprint that will also like guide you and help you get to the actual code that you need much faster than if you were just to sit down and write in a piece of paper the kind of features that you want, right? This is doing that, but going one extra step and understanding what your code has to look like from the start. Another very funny one is that you have to write all your tests before you do anything else. And if you think about it, it makes no sense. Writing tests requires you to know what your system is going to behave like. It requires you to understand every single piece of logic that you have to write. And that is why TDD is an iterative process, because you kind of also explore that behavior and you adapt it, you enhance it, and you expand it as you go along. You can't have all the behavior in your head and just say, okay, these are all the tests that I'm ever going to need, and then I just have to fill in the blanks. No, that's not how it works. You just iterate over small chunks of logic to get small wins, small piece of behavior that you know you're going to need. And then you look at it and say, okay, now that I know this, let's move on to the next one. What would that look like? That's how you go about it. It's not the other way and say just write all the tests, because also that's kind of one of the major problems, because that's also like a wall that a lot of developers face when they are looking into starting with TDD and say, okay, let me just sit down, write all the tests. And then when they stare at the blank page in their IDE and say, all right, what do I do now? How do I know what kind of tests do I have to create? They just don't know where to go, and then switch immediately back and say, you know what, screw TDD. Let me just write the code I know I need. So instead of that, just go smaller. Just think of a single behavior that you want, that you know you want, and then move on from there. Another one is that TDD is all or nothing, essentially saying you either write your entire product using TDD or not at all. And that's not true. You can definitely use TDD in just some critical or crucial areas of your system. And then if you want to, if it works for you, just expand into the rest of the project. And, obviously you will have to add tests for code that's already written, which is not TDD, but it is a process for you to go through and eventually reach a point where any new feature, any new piece of code that is written using TDD. But it doesn't really have to be from day one, or it doesn't really have to affect everything. Clearly, if you do it on the most critical aspects or of your business logic of your product, then it will ensure that those critical aspects are well designed, are more maintainable, are tested properly, and so on. Finally, the last one is that TDD just generates way too much code, way too many tests that it just makes the overall product too hard to maintain. And that's quite the opposite, actually. Again, and this is something that I've been repeating throughout the video, but the process of TDD makes you think of your code from the outside. It makes you think of the API, essentially, the public API that you will have. It makes you think about concepts such as dependency injection, which is something that we haven't really touched on this video, but if you go through TDD, you will have to face that one. So in other words, the process of going through TDD helps you design better code, cleaner code, more maintainable code, and testable code. How is that worse than not applying any of those concepts? So no, TDD is not going to affect the maintainability of your code in a bad way. It's actually the opposite. And to sum it up, TDD is not just a testing tool. It's a mindset shift. It helps you to design and write more maintainable code, testable code, and cleaner code overall. Just remember, start small, get feedback fast, and then iterate. So remember, Red-Green-Refactor. That should be etched in your forehead, essentially. It might take some practice, and you might get frustrated at first. It's not going to be easy, especially if you've been doing it a different way for a long time. But once you get the hang of it, you'll see the benefits and you'll be able to move way faster than before. And that's it. That's the video. If you liked it, if you found the video useful, remember to give the video a thumbs up. And don't forget to subscribe for more content like this. Thank you for watching, and I'll see you on the next one. Bye.